Hello everyone, welcome back to this algorithm with Python series, and in this video we are going to learn about merge sorting. I will just simply write here MS, that means merge sorting. So we will implement this algorithm on an array which will be unsorted, and then we'll use this algorithm to sort that array without writing any loops. So if we write loops, then the time complexity of uh, this task increases to big of n square or big of n cube sometimes. But using this merge sort, we can limit our time complexity to big of n multiplied by log n. So that's a way that we can optimize our uh, task in terms of time complexity, and we will also use constant space. So I mean, in terms of space, it will be big of one. It will be constant. So today we will discuss that what is the optimal way to do sorting. So I'll just simply go ahead and remove this for now, and I will create a simple random array which is not sorted. So I can write 47, 1, 23, 49, 100, and let's say 9. So we have 1, 2, 3, 4, 5, 6. Okay, we will increase another. Wait a minute. So now we have 7 entries in our array. So when it comes to merge sorting, we use a rule, which is a very famous rule. We say that divide and conquer. So we will divide our array into parts, and then we will achieve the task that we are looking for. So we will divide this array based on the midpoint. So for example, we have a midpoint this. So on this point, we will divide our array. This array will have two parts. The first part will be 47, 1, 23, and 49. So this is the left part of the array, and the right part of the array will be, let's say, 100, 9, and 12. I'll just go ahead and remove this and rewrite 9 so we can see it more clearly. So we have this part, and then we have this part. Now we will further divide these parts into more smaller parts. So I'll just simply go ahead and change the color. So it will have again two parts. The first part will be 47 and 1, and the second part will be 23 and 49. Same will happen here. We will have a part 100, and then we will have a 9, and then the second part we will have 12 only. Okay, so now here we will perform sorting on individual level. I'll just simply go ahead and reduce this a little bit so we have more space. Okay, so this sub array will become 147. We will sort this at this point, and this array will become, it will remain same because it's already sorted, 23 and 49. 23 is smaller than 49, so it is already sorted. Then we'll talk about this. 9 is smaller than 100, then 9 will come first and 100 will come second, and this will remain same because it is the only number. It has nothing to compare it to. Now what we have to do is we have to go back to I mean to its original size, right? So in each step we will keep adding or we will keep appending these two subarrays, and it will become of this size, and then we will append these two, and then it will become of this size, right? But uh, in order to append these two subarrays, we have to keep in mind that we have to sort our resulting array. Like if, when we will add these two subarrays, and it will become array of this size, then we have to keep in mind that the resulting array will be sorted. So we can do this by simply adding a condition in it. I'll just remove this. And the condition is whenever when you will be creating an array from these two subarrays, you have to compare the left items of both of these arrays, and the shorter item will be added into this array first, right? So, for example, this subarray has the left item. This is the left item, and this subarray it has left item this way. So we will compare. In this case, one is smaller, right? So we will remove one from here, and we will add one here, right? Now the pointer of this subarray will move from 1 to 47, right? Now the left item of this subarray I mean, is 47 because it's the only item. So it's a left item, right? We will again compare 47 with 23. This time 23 is smaller. So we will exclude this from this subarray, and we will add it into this array. Now the pointer of this subarray will move to 49. Now we have 49 in this subarray, and we have 47 in this subarray. So we will again compare both of them. This time 47 is smaller, so we will terminate this from here, and we will add it into this array. And now we have 49, so 49 will come after that. Now same thing will happen here, right? So we can say that with the help of these two subarrays, we are making an array. So in this case, the left of this subarray is 9, and the left of this subarray is 12. We will compare. 9 is smaller, so we will remove 9 from here and add it here. And the pointer from 9 will move to this. Now the left of this subarray is 100, and the left of this subarray is 12. We will compare. This is smaller, 12, and so we will remove it from here, and we will add it here. Right now we have 100 only left, so it will come here. So I'll just simply go ahead and reduce this a little bit more, so we have more space. Okay, I will change the color of my pointer. Now we have these two subarrays, right? And with the help of these two subarrays, we will create the original sized array. So the array will be just like in the previous layers. We will compare the leftmost item of both subarrays. Now the leftmost item of this array is 1, and for this subarray is 9. So we will compare. Obviously 1 is smaller, so 1 will be removed and 1 will be added here, and the pointer will jump from 1 to 23. Again we will compare 23 with 9, because in this subarray 23 is the most left item, and in this subarray 9 is the most left item. So 9 is smaller, so we will remove this from here, and it will come here. So the pointer will go there. Now 23 is the most left item here, and 12 is the leftmost item here. We will compare. 12 is smaller, so we will remove this, and 12 will be added here. Right now the leftmost item in this subarray is 100, and the leftmost item in this subarray is still 23. We will compare. 23 is smaller, so we will remove 23, and 23 will be added here. Now the leftmost item is 47, and here the leftmost item is still 100. We will compare. 47 is smaller, we will remove it from here, 47 will be added here. The pointer will go to 49. Now here 100 is still the leftmost item, and now in this subarray 49 is the uh, leftmost item. We will compare. 49 is smaller, so we will remove it from here and we will add it here. And now 100 is left, so 100 will come here. And you can see this array has been sorted in a correct form. Right, so that's how your merge sort algorithm works, and that's how it divides your original array into subarrays, and then again it divides those subarrays into more subarrays, and then at the lowest form it performs sorting, and then what it does is it adds those sorted subarrays to create bigger arrays, and then it adds those bigger subarrays to create your original sized array. But the only difference is this time this original sized array will be sorted, and that was our task.